Assalamualaikum and good day. In this video, I will explain the solution for tutorial 5, question number 3. So this is the question given, and as you can see here, the circuit in this schematic not only has resistors, but there are also other components, other loads, type of loads. This is one capacitor, and the capacitor unit of capacitor is farad, and another one here is an inductor, and the unit of inductor is H, or we call it as Henry. 20 millihenry of inductor, and also one capacitor with a value of 5 millifarad. In a if in a DC circuit, you can see that the Vs or the supply is one constant value, but here Vs is given as a sinusoidal waveform. So this is an AC signal. So you have to change everything into a frequency domain. Now this circuit is in time domain because we have T here. So we want to change it into frequency domain. First, what you need to do is change Vs into V frequency. Okay, so how do you do that? Simple. This is your Vs, the full equation, 50 cos 200 T, and that's it. No phase shift, phi. And in order to turn this into a frequency or phasor, we're gonna take the amplitude 50. This is the amplitude, and also the phase shift, that is 0. So this is your phasor representation of your input supply or power supply, AC supply. Next is you need to represent all these components, all these loads into a frequency as well. These are all in, this is our resistance, this is resistor is in resistance value, capacitor capacitance, and the inductor has inductance value. So we're going to change all this into a one common unit, and that is an impedance. This is an impedance, and the unit of impedance is ohm, just like a resistor. A resistor, the unit is ohm. Inductor unit is Henry. Capacitor, the unit is farad. So we're going to change all into an impedance, and this impedance will have a unit of ohm. So how are we going to change that? First, we need to do some table of conversion. This is R. So R is a resistor and the value is 10 ohm. So how do you change R? R is if the value, resistance value is 10, then Z, or the impedance value of that particular resistance, is just the same thing. You don't need to do some further calculation. So if R is 10, then R meaning representing that resistor, so is also 10 ohms. That's simple. So next one, let's change this C, or the capacitor here. So the capacitor value is 5 millifarad. Okay, 5 millifarad. And if you want to change to an impedance, I would like to do a subscript of C to represent capacitor. You're gonna do some calculation here. And how do you change from C to Z? is you're going to take that C value and put into this equation here, J omega C. What is omega? Omega, the angular frequency that we have learned before. Where in this equation is your angular frequency? That is here, 200, because any value of AC signal will have this cosine theta as a function of omega t, and this 200 is your angular frequency, 200 radian per second. So continuing this work here, this J is actually the imaginary. So in complex numbers, you have two parts. You have real component, and also you have imaginary. Okay, for example, let's say you have an equation of y, and this y has a real component of, like, for example, 3, and then you have j4. So meaning the real part of this complex number y is 3, and the imaginary part is 4. You can also write this as 3 plus 4i. So I'm gonna, in my steps, I'm gonna use this one, because in your calculator, you're gonna key in just like the sequence of this. 3, you're gonna key in 3 plus 4, and then you're gonna find an I number on your calculator. So based on your calculator, you're gonna find that. Okay. So I'm gonna teach you later, not in this video. So you have to okay. Give me a minute. Okay, so substituting all the values, this J, I'm going to make it to backward. So omega is 200, C is 5 milli, and that I, imaginary part, I'm going to multiply it with I. So using your calculator, try to calculate, and you should get this value, negative 1i, or negative I. Okay. Next is to convert this inductor L into an impedance as well. So you have L with a value of 20 millihenry, and changing this inductor into an impedance will require you to use this equation here, J omega L. And all these equations you need to remember, because if you don't remember this, you cannot make progress in solving this problem. So I'm gonna take this J to the back. So omega is 200. L, the value of L is 20 milli. Don't forget that milli. And don't forget also that J that we move from the front to the back, I. So keying this into your calculator, and you calculate, you're going to get this value of 4i, positive 4i. So try to redraw back this circuit, just to make sure that you get you understand what I'm trying to say here. Gonna rearrange so that you can see how these components, or how these loads are connected together. Okay, so by seeing this, you can see that this is your ZR, this is your ZC, and this is your ZL. and this is your supply, that is Vs, and that's it. And you want to find this Is here. What is that current flowing into this circuit? So similar case for DC circuit. AC circuit will also require you to find the total summation of impedances or resistance. Okay, so if in DC circuit you calculate for total resistance, in AC analysis you're gonna calculate for total impedance, ZT total. So the total here, how do you gonna add up? They are just like resistance. If they are in series, you're gonna add them up. Just like that. ZR plus ZC plus ZL. That's it. And if you have something like in parallel, you have also to add them as if the like the one that you did with parallel resistors, okay, to calculate the total resistance. So you want to calculate the total impedances. Your ZR is 10, ZC is minus I, and your ZL is plus 4I. What is the total? So in this complex number, you only add real numbers with real numbers and imaginary numbers with imaginary numbers. You cannot add real with imaginary numbers. They have to be the same kind, okay, in order to make the summation or any operation. So in this case, the real number is only 10, so you're gonna leave 10 as 10. And then this one here, negative I plus 4I, what is the total? You're gonna get plus 3I. So this is your total impedance. So in DC circuit, you know about V equals to IR. Okay, so in AC analysis, you just replace this R with a Z. So to find I, you rearrange this equation and you have to take V over divide it with the impedance value, then you're going to get your current. So same thing here. In order to find IS, the current that flows into this circuit, you have to take Vs and you have to divide it with the Z total. So there are two ways of calculating this one. It looks simple, but it depends on your preference. Which one do you prefer? The first one, I will take Vs. So Vs is 50 and the Z total is 10 plus 3I. Depending on your calculator type, you can directly do this operation. This is a polar form, this is a complex form, and I think most calculators can do the calculation directly. Okay, so but if you don't want, if you're not sure, we can like convert this either in, if you want to stick with phasor form, change this denominator into a phasor form, or if you want to stick to complex number, you have to change the upper part here or the numerator part here into a complex number. So depends on your preference lah. So I have two suggestions here. Like for example, if I want to change to this complex number into a phasor, so using your calculator, 50, 0, change this 10 plus 3i into a phasor, and you're gonna get 10.44 with an angle of 16.7 degrees. So using your calculator, this one, if you have your your numbers in phases, and you are doing multiplying or division, it is a bit simpler to do. You just take the magnitude, you divide it using your calculator, you're gonna get 4.78. And as for these angles here, you just take the bottom angle minus it with the below angle. And 0 minus 16.7 gonna give you negative 16.7. So this is your IS in phasor form. Okay, so in phasor form you can keep it in phasor form, because now we have to change this IS into IS, small letter I, meaning we want to change this phasor form into a time domain now. So how do we make this? Okay, now we need to write the amplitude. What is the amplitude of this signal? It is 4.78. And then, since we are converting it from a phasor, so the converted signal would be cosine. And then omega t, our omega is not changed. We do not change our omega. Omega remains the same before and after your calculation. So omega is still 200 t. So now, do we have any phi? Yes. The phi, or the angle, is 16.7. The phase shift is 16.7 degrees. So this is your equation, or your answer for this, finding the current in time domain based on this given circuit. Okay, you can just check your answer whether it has the same number or not. Yes, amplitude 4.789, 4.789, and also the phase angle 16.7. Okay, thank you.